Today we are discussing about Prim's algorithm in DA, design analysis of algorithm. What is Prim's algorithm? Prim's algorithm is useful for calculating minimum cost spanning tree. Means we can calculate the minimum cost of a spanning tree. And spanning tree is a subgraph of given graph. In given graph, spanning tree means it is a subgraph of given graph. Spanning tree should produce minimum cost than other remaining spanning trees is known as minimum cost spanning tree. Means it should produce some cost. So, Prim's algorithm, we can start with any vertex. Start with any vertex of the graph. We can start from any vertex of the graph here. So, we have to find out all the edges associated with that vertex. So, if we select one vertex as A, so we have to select all the associated vertices. Means here associated vertices of A is C and B. So, we have to select this. And from the available edges, select the minimum cost and add that edge to the tree if not forming any cycle. If it forms cycle, discard the edge. So if we select one vertices, it adjacent edges are C and D. So we have to take minimum cost from these two vertices and we have to add to the tree if it is not forming any cycle. If it is forming any cycle, we have to discard that edge. Okay, this is Prim's algorithm. So now here we are taking one example. Now here we are taking one example of Prim's algorithm. Here we are taking A, B, C, D, E. That means 5 vertices we are taking. We are taking 5 vertices and we have 6 edges. These are vertices. These associated lines are called edges. Okay? Edges. So we have cost A, B, C, D, E. So from A to B, the minimum cost is 7. A to C minimum cost is 3 and C to B minimum cost is 4 and C to D minimum cost is 10 and B to D minimum cost is 9, B to E minimum cost is 11. So we have to find out the minimum cost for the spanning tree. Okay. So here the property. So we have 3 main properties in to find out minimum cost of a spanning tree. So these are 3 steps. 3 properties. Spanning tree should contain all the vertices of the graph. So we are forming a spanning tree. So that spanning tree should contain 5 vertices, all the vertices of the graph. But if the graph contain n vertices, if graph contain n vertices means we taken 5 vertices. So if graph contain 5 vertices, then the spanning tree should contain n minus 1 vertices. Means we are taking 5 vertices. So the spanning tree should contain 5 minus 1 edges. Means that is 4. Okay, 4 edges. Spanning tree should not contain any cycle. So spanning tree a cycle form avaddu. If okavela form aయిందనుకో, so we can discard that edge. Okay. So we are taking first step. So this is the example of graph A, B, C, D, E. So from vertices A we are starting. So let us start with A vertex. So let A be a starting vertex. So we have to check all the associated vertices of A. A has associated vertices C and B. So from A to B the minimum cost is 7. From A to C minimum cost is C. So again A is not going to B, D and E directly. So we are not considering these edges. We should consider only A to B, A to C. So from A to B the minimum cost is 7 and A to C minimum cost is 3. So from these two we have to select the minimum cost, means least cost. Okay. In these two, 7 and 3, which is least cost? 3 is least cost. So we have to take this edge and add to the spanning tree. So like this, vertex A and we should add the least cost, means minimum cost. Add to the spanning tree, that is 3. Okay. Again, this is the remaining edge. New vertex is C. So find all the edges associated with C. Means here we got the new vertex as which one? C. So we have to take C as new vertex, and from C we have to check all the associated vertices of C. So from C we have associated vertices from C to A, C to B, C to D. Means C to A or A to B, A to C already completed. So we should not consider this. So from C to B, C to D we have to consider. C, A to B as it is like that only, because it is not deleted. Okay, only this one completed, so we should not consider this. So C is new vertices, means again same, from C to B 4, from C to D 10. Okay, so from these three we have to select the minimum cost, means least cost. Which is least cost? 4 is least cost. So C to B we have to add C to B edge. So here C, A to B already there, so we have to add C to B, that is 4, cost is 4. Again the new vertex is here B, so again we have 2 remaining edges, so new vertex is B. So new vertex is B. We have to check all the associated vertices of B. Here associated vertices of B where from B to A already it is completed, like A to B, so we should not consider that. So B to C also already completed, so we are new vertices what are there? From B to E, B to D. So from B to D minimum cost is 9. So from B to E minimum cost is 11. So we have to check all the 4 which is minimum cost, means least cost. So here 7 is least cost. Okay, 7 is least cost. If we add A to B, that is A to B like this, if we add these two, it will form cycle. So we can discard this edge from A to B. So okay, we can discard this edge from A to B. Again from these three, which is minimum cost? Means least cost, that is 9, from B to D. If we add from B to D, anything is forming? No forming. So we can add. We have to check if the cycle will form or not. If cycle will form, we have to discard the edge. So what is cycle? Cycle means it contains a path. Okay, cycle means it contains a path in which the starting vertex and destination vertex are same. So cycle means here C, from C to A, A to B, again B to C. C, starting vertex and destination vertex are same, that is called cycle. Okay, so now we are adding from B to D, because this edge is not forming any cycle, so we can add it directly. Okay, now remaining vertices what are there here? These 2 edges are there, C to D and B to E. So C to D 10, B to E 11. So here we added D. Okay, now here what happened? D is the new vertex of the graph. Okay, so new vertex of the graph is D. We have to check all the associated vertices of D. Okay, we have to check all the associated vertices of D. What are there? D associated vertices, D to C, D to B, but it already completed, so we should not consider. Okay, again see, from here we have 2 edges. Okay, new edge is D, no new edges of D. New vertex is D, but no new edges for D. Okay, we have to select from these 2 only. So C to D minimum cost is 10, B to E minimum cost is 11. So from these 2, which is minimum cost, means least cost? This 10. If we add C to D, is it forming any cycle? If you form C to D, is it forming cycle? Yes. So we should not consider this edge. We have to discard that edge. If we connect C to D, the cycle will form. So discard that edge. So from B to E 11. Okay, this now remaining last edge is this one, B to E 11. So we have to add this to the cycle. If it is not forming any cycle, if it is forming cycle, we have to discard that edge also. But see, from B to E, is it forming any cycle? No. Okay, no. So we have to connect this edge of 11. So is it forming any cycle? No. Okay, so all the edges are covered. So see here, 1, 2, 3, 4. All the edges are covered. This is minimum cost spanning tree with the help of Prim's algorithm. So minimum cost spanning tree with the help of Prim's algorithm. So here see, from A to C, this to this, this to this, this to this, there is no forming any cycle. Okay, if it is forming any cycle, we have to discard that. So how we can find out minimum cost? So cost of spanning tree, A to C 3, C to B 4, B to D 9, B to E 11. So 3 plus 4 plus 9 plus 11, that equals to 27. This is the minimum cost of a given graph. Okay, so we formed a spanning tree without forming any cycle. See here, we have 1, 2, 3, 4, 5 vertices and 5 minus 1 edges. Yes, no? 1, 2, 3, 4 edges, 5 vertices. Okay, we what is these 3 properties are satisfied? Yes, no? What are 3 properties? One is spanning tree should contain all the vertices of the given graph. If graph contain n vertices, then the spanning tree should contain n minus 1 edges. Spanning tree should not contain any cycle. So here we proved it.